Good afternoon, chemistry students. Welcome back. Chapter 7. It's about chemistry. Of course, it's about chemical reactions. And today we're going to learn about the types of reactions. As you will notice, we're going to be learning in the same format now in the Smart Notebook. And so use your notebook, use the next input page for your notes, preferably the one that's right after the next or the last used page, basically. Let's first start out with the types of reactions. We got two of them for you right here. What are synthesis and decomposition reactions? Again, just put it in the next input page because you have plenty of space in your notebook and we want you to have a lot of space possible, so don't feel worried about having less or too little space to work with, because we're going to be using the notebook quite a bit in this case. Okay, what are these reactions? Again, if you need to pause to write this out, do so. Let's talk about synthesis reactions. We label it SY. What that means is that two or more reactants combine to form one product. And so if we have two reactants or two atoms or two molecules, what's going to happen is that if we give it a little bit of heat and we react it together, it's going to create just one product. The best reaction, or the best case that I have here for you, is a reaction between oxygen gas and hydrogen gas. What are they going to create? Well, if we give a little bit of energy for them, they're going to create water, which is just one product. And so we have a good example here. Now write this down. This is very important. A plus B yields AB. And so that AB, when it's together, represents just one product. These are two reactants coming together to form one product. Now, we have this reaction here. Magnesium solid plus oxygen gas yields magnesium oxide. Right? It's an ionic compound as magnesium oxide. And you'll already notice that it's already balanced for us. I didn't want to really erase a lot of stuff here, but I wanted to let you know that these are some things we have to worry about when, again, dealing with chemistry and balancing, and for the types of equations. So, 2 magnesium on the reactant side, we have 2 magnesium on the product side. 1 O2, right? So we have a total of just 2 oxygens on the reactant side, and this 2 is distributed to this oxygen as well, so now we have 2 oxygens on the product side. So we're all balanced out. That is synthesis. It comes together to form a product. Next up we have decomposition, or labeled DE for short. It is the opposite process to synthesis. One reactant breaks down to form 2 or more products. So imagine going this way, starting here, and then going backwards. That's a decomposition reaction. And you'll see it here. AB breaks down to form A plus B. A good one is going to be hydrogen peroxide, H2O2. What's going to happen is that over time this naturally breaks down because the bonds between the oxygens in H2O2 is very, very, very weak. And so even sunlight is able to break it. So it's going to break down into water and oxygen gas. Now, don't forget that we have to balance, right? We have to keep that inventory on both sides the same. So we have 2 H2s. So that 2 H2s means I have a total of just 4 hydrogens. Do I have 4 hydrogens on the product side? Yes, I do. Right? 2 H2, 2 times 2 is 4 hydrogens. Now I have 2 O2s. So 2 O2s means I have 4 oxygens. Do I have 4 on this side? Well, I got 1 O2 here, which is 2. And then I got this 2 here that distributes to this oxygen. So I have a total of 2 plus 2, which is 4, which means we do have what we need. Now what's this up here? MnO2. Well, it's manganese dioxide. And why is it up here though? We call it a catalyst. And so what's going to happen is that sometimes we're going to have some compound or some molecule up here. They're not going to be a part of the reaction. What's going to happen though is that you're going to put that into your reaction. It is going to speed up the process of breaking things down, but it will not be chemically involved. And so if I put in 2 grams of MnO2 into a test tube, and then I added H2O2, what's going to happen is that MnO2 is going to catalyze the peroxide, and it's going to break it down much faster. Probably about 100,000 times faster, if not a little bit more. Because we can't see the H2O2 breaking down, but once we add this MnO2, you can immediately see a process where it breaks down. Once that reaction ends though, I'm still going to have that 2 grams of MnO2 that I had before. Nothing changed with it. It just sped up the process, and in the end, I still have what I just put in. So those are the first two. Let me get a screen shade here. Now, this is the next page for you, so I'd recommend getting another new fresh page. Now we have a few more reactions to talk about. Now this one is, what are single and double replacement and combustion reactions? So we have 3 things here. We have single, we have double replacement, we have combustion. Let me highlight those or underline them. So we have 3 specific and different reactions than before. Let's talk about them. Again, pause the video if you need to write this down. Again, on a new, fresh input page, preferably the one after this one, the one that we just worked with. Alright, single replacement, or in short form, SR. One element replaces another. So in a reaction, what you may see is that we have an atom that's going to be reacted to a compound, and that atom comes in and kicks off another atom in the compound. A plus BC, so we have our atom, we have our compound. That atom's going to come in, it's going to kick off B, and now B is by itself, and now A is now combined with C to make AC. Pretty good one that we've had is this one. We have zinc, we have hydrochloric acid. What's going to happen here is that the zinc's going to come in, it's going to boot that H off, the zinc's going to then combine with the chlorine, and now what's going to happen is that this H is by itself, it's going to turn into a gas. And so now we have H2 gas, and then we have ZnCl2, zinc chloride. So zinc comes in, kicks off the H, now zinc is now bonded with chlorine. We see that happening over here, and we have H2. Now, I believe this is actually my notes. I actually wrote these notes last year. Anyways, we can see a few things here. Don't forget, we have to balance it on both sides, right? I have 1 zinc atom here, I got 1 over here. That one's good. I have this 2, which is distributed on the H and distributed on the chlorine. So we have 2 hydrogens, 2 chlorines. Let's check over here. H2, that's 2 hydrogens. That is correct. Chlorine, I got that little 2 down there. That also means I have 2 chlorines. So we are balanced. That's a single replacement reaction. Now you can guess what's the next one. If it's a single, we got a double after that. Double replacement, or short form DR. 2 elements are replaced now. So you can imagine the same process up here, but now we're just switching them up a little bit more. A plus B, so A is combined with B, plus C, D, so C is combined with D. What's going to happen now is that A and C, they are going to switch. They are going to, basically, A is going to come in, bind with D. C is going to get kicked off and bind with B. And so what we'll see now is that it's no longer going to be AB, but it's going to be AD, because A is now going to be combined with the D on the right side here. And the C is going to come over and be binding with B. So now we have AD plus CB. And so we are replacing these, in this case, twice. A double replacement. Let's see a reaction here. Oh yeah, this is definitely my work. I can see a lot of very messy handwriting. Anyways, we have BaCl2. We have CuSO4. And now what's going to happen is that Ba, let me get rid of some of this stuff. Just to help us out a little bit more. That barium on barium chloride here, it's going to come in, it's going to swoop over, and it's going to kick off that copper, that Cu. Now, where is that Cu going to go? It's only got one place to go. It has to go back to the chlorine. And so the barium's going to come in, kick off the copper. The copper is going to go over here and replace the barium. And so now barium is going to be combined with the SO4. That's a polyatomic ion, right? It's sulfate. So barium is going to come over with the sulfate. The copper is going to come over with the chloride. And so, instead of barium chloride now, is now going to be barium sulfate, because we've kicked it off. We kicked out that copper. And now copper is going to come over with the chlorine, make copper chloride. We have barium sulfate and copper chloride. We have made that double replacement between both the atoms. In other words, you can just switch the cation. Switching the cation, don't forget, cation means positive ion or metal. So just switch the metals. Switch the metals on both sides, or on both molecules here, and then you'll find an entirely new product. That's all it is, basically. All right, we got one more for you. It is combustion. So, in combustion engines, in certain engines like this, we need a specific fuel source. We can use gasoline, we can use kerosene, we could use lighter fluid, even, if you want to make a barbecue, right? Well, in this case, what's going to happen is that we're going to need something from the atmosphere. We're going to need oxygen from the atmosphere to help us out. So, a substance that burns in O2. Now, what's going to happen, though, write this down too, we have CH4. That is methane. It's a natural gas. Now, what's going to happen here, it's going to react with oxygen gas. Let me get rid of some of this stuff here. Here we go. It's going to get rid of the oxygen gas, but it needs to use it first. So O2 is our fuel source with methane. What's going to happen is that with a little bit of heat, it's going to react, and if you've seen engines work, they have to use fuel with oxygen to make power, basically. And so that oxygen is going to be reacting, it's going to break down and react with the CH4 to make CO2 and H2O. And so with combustion reactions, you will always see two products, CO2 and H2O. That's going to be a very key important thing to remember when looking for a type of reaction. And so if you always see the products being carbon dioxide and water, then you can say without a doubt that's going to be a combustion reaction. Alright, hopefully this makes sense. Again, just leave a question in the discussion if you have a question. And I'm going to post another video today along with this that goes through some of the homework just so we all are on the same page. Alrighty, have a nice day, and I'll see you in the next video.